is Daniel Gruber. I see you're all ready to go. He's the founder and CSO at HPC Gridware, and he's also going to talk to us about HPC scheduling. So all yours.
Thank you very much. Hello? Okay. And this is working like that. Okay, yeah, thank you very much for being here or having the opportunity to present our company here. I think it's even the very first talk or public, more or less public talk about our new company, HPC Gridware. I'm co-founder of this company. It was founded 2.5 years ago in Regensburg, beautiful Regensburg in Germany. What we are doing is we are a product-focused company. We are providing two products. One is Open Cluster Scheduler. The other product is Gridware Cluster Scheduler. Job scheduling is not new to us. We are doing that since a very long time. Basically, my two co-founders and I, we met at Sun Microsystems. We developed Sun Grid Engine 15 years ago or longer there. And even my co-founder, they work since the 90s on the same problem, job scheduling on the predecessor, which we will see later in the history. Yeah, this is the agenda for this talk. We start looking a little bit back where the Open Cluster Scheduler code comes from, then comparing the two different versions we are providing, and then the main part will be about workload compatibility. So you can run any kind of workload inside Open Cluster Scheduler and Gridware Cluster Scheduler, and yeah, and you need supporting functions from the scheduler side for that. Okay, and that includes, of course, our newest features from the 9.1 release. So we just released 9.1.2 version. And okay, and then we conclude with everyone's favorite topic, which is AI agents. So they are not the future, they are there. Everybody is using AI agents for developing code and for doing presentations and whatnot. And you can also attach your AI agent, your Claude agent or whatnot, to Gridware Cluster Scheduler already today for helping you with your daily workload. Okay, so where does Open Cluster Scheduler come from? It is originated at the University of Florida in the 90s. A system was created called distributed queuing system. And a couple of years later, a company in beautiful Regensburg, Germany, absorbed the code under the name Codeine. This company was then bought by Sun Microsystems, and this very same code base was then published and made open source as Sun Grid Engine. I joined Sun Grid Engine at a pretty much late state at that time. At that time, it was said it is 10,000 data centers which were using Sun Grid Engine. So we know now other systems which are having these numbers. And I think, or we think, this came to a specific reason. And this is Oracle bought Sun Microsystems. And Oracle was not so interested in several parts of Sun Microsystems. So we built the first version of Oracle Grid Engine after the acquisition. So it was closed sourced by then. And then we were thinking about changing the company. So my two co-founders, I and two other guys, we went to a company called Univa. Univa was a good name at that time. They were also a reseller of Sun Grid Engine. And yeah, basically the founders of this Univa company coined the word grid computing. So we were thinking, or I was thinking, it's a good opportunity there. So then we built Univa Grid Engine. Univa has been acquired by an engineering simulation company, and this has been recently acquired by a 300,000 people or workforce big German company. Okay, 3 years back, these two other guys, they came to me and said, yeah, we want to continue to develop the same workload manager, but we want to continue it in an open source way and providing then a commercial version on top of that. And this is what we are doing since 2 years. So basically, you can find on GitHub our Open Cluster Scheduler source code. If you can build it there, you can look at all functionalities. Of course, you can also contribute to that. And you can also just start it on your laptop within containers. So in this repository, I hope you can see it here. There is a quick start repository which contains a Docker Compose file where you can spin up a 3-node compute cluster just with Docker Compose up, and then watching the logs until everything is installed, and then you can log in and play around with the cluster. So it's completely unlimited. And new files are added with Apache license. Old files have a SSL license, which is like Apache license, so very, very friendly, unlike GPL maybe for some companies. So what we are doing is we are building Gridware Cluster Scheduler on the very same code base. So when we are creating a new release, a new version of Gridware Cluster Scheduler, we are building also an open cluster scheduler version. And you can download that, so you can build it on your own if you want, but you can also download this compatible version from our website without registering. We are not collecting the data about that. And just use it in your cluster. But you are then on your own, self-support, and so on. With Gridware Cluster Scheduler, you get some enterprise goodies, which we'll see later, a few of them. And then, of course, this is our supported version. So this is how our company works. So again, we are product-focused companies. We work with consultant companies and service integrators. And this is how we can reach out more people. Okay. Ecosystem integration is the major thing, of course. We want to run any kind of workload, and from that perspective, we are using the legacy of Sun Grid Engine, SGE. So there are tons of applications which have Grid Engine support, or SGE support, or Univar Grid Engine support, and typically they are running unchanged directly on our workload manager, on Open Cluster Scheduler. Examples are Nextflow. We just heard about Open On Demand. They seem to have a Grid Engine integration. I did not verify that, but everything which supports Grid Engine works on top of us. Especially important are MPI libraries, of course. So OpenMPI, this has, Sun Microsystems supported that back 15 years ago, very much. So they have a Sun Grid Engine integration, which is still working today. The same is true for Intel MPI, MBA Pitch, and so on. So you can just run these applications there. And the other thing for application integration is, we keep our command line compatible. We are not changing environment variable. So if you have a script which was running 10 years ago or 5 years ago on some Grid Engine system, it runs unchanged on our system, and we will keep this compatibility forever, most likely. The other thing is our accounting file. So this was a major change we introduced at the very beginning. We had a very stiff accounting file. So when you install the system, you have a file-based accounting. Now you can opt in also for databases. But it's a file-based accounting, which is a colon separated, so you had to write your own parser. But now it's JSON line format, which means it is extensible. And we are using that, for example, for our GPU integration, so you can have per job GPU accounting inside, or for other jobs, you can have other extensions inside the very same accounting record, which is a complete JSON expression or in JSON format. And and then the administrator, of course, can add its own extension to its workloads. Okay, we have 2 versions now in production at customers. This is the 9.1 version, and 9.0 and 9.1. So the minor version is 9.0.13 is the latest one. The patch version just means you can replace the binaries without any fear, and it's just working then. For 9.1 version, going from 9.0 to 9.1 version, you need to run an update script, which converts the persistent spooling files into the new version. Okay, 9.0 was all about stability, getting this code base to a stable base, and introducing a much, much better multi-threading. So the colleague which introduced multi-threading there, he worked on this topic for a very, very long time. And we are thinking we have the best multi-threading implementation in all these Grid Engine variants there. So it was also said by some customers which have 20 years grid engine experience that, yeah, it's very, very fluent. So even you are submitting hundreds or thousands of jobs at the same time, you can query the cluster status in a very, very fluent way. 9.1 version was all about security and performance and AI readiness. So key point here was adding a new TLS encryption. Before we had a secure mode called CSP. The disadvantage with this CSP mode was it was very complicated for the administrators. So that resulted in a very, very low adoption of the secure mode, which then everybody was running their cluster unsecured, which has now major problems with these namespaces, with containers, and so on. So now we have a very simple to use secure mode. So during installation time, you can just say -TLS, and then certificates will be created and they will be automatically renewed and so on. So the administrator does not have to do anything anymore. The same is for Munch, for authentication. So we switched to Munch. Everybody knows, of course, from the other administrators. So you can just install Munch and share the key. And then during installation time, you're just saying -Munch, and then that's it. And then the system uses transparently Munch for authentication between hosts and also for containers, of course, for security. Another thing is larger clusters, there is the risk of denial of service attacks. So we have now very fine-grained resource limit, request limits, where you can define from which host or from which user or from which application how many requests are allowed per second. Another major thing I mentioned briefly already was the new database integration. So we can now integrate reporting and accounting into MySQL, Postgres, and Oracle databases, so that you can just create your dashboards or can connect your known familiar tools through SQL, getting the data here. 9.1 came with another bigger change, which was a new core memory binding. So 2009, Sun Grid Engine introduced core memory binding already in a very, very simple way. This was completely reworked. We have new command line parameters for that. And what I especially like is the capability to bind not just on core and NUMA nodes, which you potentially could do before, but now you can also bind on things like level 3 caches. So we have seen yesterday a talk from AMD. They have these CCDs and 8 cores using the same level 3 cache. And now you can express something like, I want to have 8 cores on the same level 3 cache, and then you have stable job run times and can optimize them on that. We also heard in the previous talks and yesterday a lot about Grafana. So we are embracing Grafana. We have a dashboard which you can just download here from Grafana Cloud. So we have a dashboard ID, which is a sample dashboard for Gridware Cluster Scheduler cluster, and the integration works in a very common way. So we have a new tool called QTelemetry. QTelemetry exposes a metrics endpoint, which is consumed by Prometheus, a time series database, which creates snapshots of the cluster state, and then you can create your dashboards about how many jobs are in which state at which time, and so on. So it builds aggregations. This is important. Then we have our first customers, or several of our customers are building chips, so they are fabless chip design companies, and they are using all licensed software. And all this license manager, the common license manager in that space is all FlexNet. And so it's very important for them to use the licenses very, very efficiently, because the license costs are more than hardware costs. So we have a license manager which just grabs the features from different license manager and installs them as resources in Gridware Cluster Scheduler so that the administrator does not need to configure them manually. This has also advantages like when a new feature is added to a license server that this is replicated directly in the cluster and available for the jobs to be requested as a resource. Newest features are license pooling. So sometimes when you're buying licenses, you're buying that for a specific license server, which is bound to a MAC address. And then you're buying further licenses for another license server, which is bound to a different, another MAC address. But essentially they are the same, and the jobs could consume either of the license from different license server. So we have, with this license pooling feature now, this license manager can query the licenses from multiple license servers and create one single resource, which is the representation of the license in the workload manager. So this makes life very easy for an administrator and, of course, for the user. And the third thing is, of course, the licenses are more used. Then MPI support, we talked about that already. So another enhancement here was a new scope request for QSub. So QSub is the job submission tool for Gridware Cluster Scheduler. Basically what you can do now is you can request different resources and maybe completely different resource sets for the master task and for the worker tasks of the parallel job. We have also a new parameter which allows to ignore these worker tasks on the master task node, the resource request, which comes close to something like a multi-slot master task support. Okay, this is parallel job. And the other thing, going back here, is we have MPI templates, so parallel environment templates. So in Gridware Cluster Scheduler or Open Cluster Scheduler, you have to define something called parallel environment, which sits between the job and sits between the resource manager. It's some kind of abstraction where you can define how the slots for the job should be allocated. Should it be a fill up? Should it be round robin? What is the starter method for this parallel application, and so on. So we have here new templates for the known parallel middlewares like Intel MPI and so on. And this gives you a very good out-of-the-box experience, which you can also use then in our new user interface. So we had in the past one, which was called QMon. QMon was written 15 years ago or 20 years ago, written in C motive. So yeah, it was good at that time, but nowadays everybody wants to have a REST-based web interface, of course. So we have rewritten a user interface for configuration, and with that it is very, very easy to create this parallel environments, especially with the templates. So it's just a click, and then you can associate it with a cluster queue, and then it is configured. So this is now very, very easy. Another thing here is the latest additions are MCP server, and which I come later to, and an ops log, which is a hash-chained log file where you can see then who changed what at which time, so you can opt in for that. And of course, people cannot remove entries because it's hash-chained, and you can query it also from the user interface. The first thing when we started, or when the first release came out, was people were asking, yeah, where's your container support, where's your Docker support, and so on. Yeah, Docker came out 13 years ago, 2013. At that time, people wanted to adopt it, but of course it has problems because Docker is running as a daemon, and the jobs are, when Docker starts jobs, they are child processes of Docker and not of the workload manager. Smart people figured that problem out and other problems, and they created stuff like Singularity at that time, which is now Obtainer, and NVIDIA comes with nroot, which we heard, and daemonless podman and so on. They tackle the problem. So from our workload manager perspective, you actually don't need to do anything. You can just run Obtainer jobs in Gridware Cluster Scheduler without any problem. The only thing might be that it might be too complicated for the user to call Obtainer run or whatnot, all these parameters, but we have hook points. We have a lot of hook points, and one hook point is the starter method. So the starter method is in between our shepherd. This is the part which starts the job and the job itself. So you can hook in Obtainer run and select your container run, your container image, and so on automatically there. And then you can configure it in a way that the user just submits their Python script, and then it ends up in a PyTorch container or similar. GPUs are everywhere. We are also supporting GPUs. We are in the NVIDIA Inception program. They are supporting startups like us, so we get early access to the latest hardware. So two things here to mention. One is we are having integration with DCGM, so we can provide things like per job GPU accounting, which ends up also in our accounting file. And the other thing to mention is that NVIDIA has their own CPU part as well, which is ARM-based. So we are fully embracing any kind of architecture, ARM and RISC-V, and also future architectures. So we verified that on their latest hardware, on Grace Hopper, Grace Blackwell, and so on DGX Spark when it came out. So you can just run Open Cluster Scheduler or Gridware Cluster Scheduler on any of these boxes with these DGX OS, which is mainly an Ubuntu version. Okay, main thing here now is really AI. You can do anything with AI. Why not querying your cluster? Why not creating diagrams of your cluster with an agent? When Anthropic released this MCP protocol 1 year ago, over the weekend we created an MCP server in the open source, and I showed them a lot of administrators and how useful it is, and I said, yeah, we want to have it, but it needs to be secure. So this was one thing. So it's off per default in our case. So you need to opt in for that, and then it is part of control our web interface. So basically we have two authentications there, encryption, and then the major feature is not to be able to change something in the cluster. So in the open source where you can do job submission, this works very nice and so on. But in our case, we just removed all write functionalities. So it's a read-only thing, just not to break anything in your cluster. And there are a lot of use cases, as you can imagine. One of the latest one is a partner of us, HPC Box. They are building a job workflow tool. And they have also their own MCP server and an agent, and they can connect from that system to our MCP server, and then you can create your complete ANSYS fluent workflow or whatnot just by talking with the agent to their system. And and then you have the capabilities of with us, you're discovering resources which are available, like queue names and slots and whatnot, parallel environment names, and they are specialized in creating these workflows. Through having a range of MCP servers, I think you can do a lot of stuff. We are working also together with POSIT, and they are currently evaluating their way of integrating MCP server with our MCP server, which I think will be very mighty or very cool. And my beloved one is creating diagrams with Claude. So Claude can automatically stream or create diagrams through the web interface. I think this is also a feature of the latest MCP protocol to stream user interfaces or have the capability for that. Doing that. And then another thing which I heard for many, many years is the question, why is my job not running? And this is far from trivial to answer in a large cluster with a lot of resources. And we also have a tool which is targeted for this, so an MCP tool, which is targeted for this task. So where does, LLMs need context, so where does the context come from? We have 6 different sources. We have a host and GPU metrics, where we have job metrics, job history, so from the accounting file we can get the data. You can also get the complete cluster configuration, which works for small clusters, but you can also have fine-grained requests of queues and single elements. And then, of course, the operation log is also available, which I think is a very good use case, because now the agent can not just figure out that there is a problem and it can solve by that and that. Maybe now it can also be so smart in figuring out who introduced or when this problem has been introduced. I think I'm over time now already. We are at the end, last slide. Now we try to expand, or we are expanding the ecosystem. So we are working with Pascal. They are building quantum computers. So we have here an integration with QMI, which is standard for bringing an HPC cluster together with a quantum computer. This is also developed in the open source, mainly driven from Pascal. We have integration with POSIT, so they are just created a launcher plugin for their interface so that you can start interactive sessions like RStudio Pro or Positron or Visual Studio Code in the cluster. And then, of course, you can run also from RStudio Pro batch jobs, which are batch jobs then also in the same cluster. So this is ready for testing. If somebody is interested, go to POSIT, which are supporting that, or go to me, and we are talking. We can make an introduction. So we are supporting that together. And then I mentioned already HPC box. Okay, last slide, really now. Credentialing continuous is the main message, fully open source, now a different name, Gridware Cluster Scheduler. AI is here. I need to run now to the airport. So if you're interested, talking to me or see a demo or something like that, I'm at ISC in Hamburg next week, booth K40. So if you come, I would be very, very happy to see you.